Yo, what's good YouTube? Welcome back to the tutorial. So in today's tutorial, I'm going to be making a projectile system. That's what it looks like. As you can see, it is a physics-based projectile system, meaning that it has gravity added to it and whatnot. So it's pretty cool. You can see it actually works on like surfaces and stuff. And yeah, I just thought it's pretty cool. I decided I'll make a tutorial on it. So yeah, make sure you guys like, sub, which I hit 2,000. It'd be much appreciated. If you guys like more tutorials this style, let me know. And yeah, drop a like, which I hit 100. You guys get the point, right? Let's get straight into it. Alright, so for this section of the video, I'm basically going to be explaining the difference between raycasting and shapecasting. So as you guys already know, when you're making projectiles like guns and stuff, usually you would use raycasting. And this is an example of how raycasting works. As you can see, you'll be given a position and a direction, as well as like magnitude, right? And then the raycast is going to fire from the origin in the direction you passed in using the magnitude. And magnitude just means like distance, like range, right? So I made a script to just make it move forward to help visualize this. So you can see here, the raycast moves forward and it will keep moving until it collides with this wall that's blocking it. As you can see, keeps moving. The moment it touches, the raycast will stop and then it will return information like the surface that it hit, the part, and loads of other information that can help you script it, right? So now we're gonna have shapecasting. I'm gonna show you the difference. So as you can see, when I run the game, the shapecast is moving, as you can see, and it's going to collide with this wall. And the moment it hits the wall, you can see it says in the output shapecast hit. So you guys can probably already tell the difference between the two. The shapecast actually has a volume, meaning you can have a specific size that you want instead of a tiny thin line like the raycast. So an actual visual example of the difference I'll show now. Alright, so to show why this is relevant to what we're creating, as you can see here, I'm going to move the raycast on a shorter wall this time. So you can see the raycast is going to keep traveling, and obviously in this situation it doesn't actually hit the wall, so the raycast will keep traveling. Now the issue with that is a fireball, we wouldn't want the fireball's hitbox or hit detection to be this small, but want it to be larger, and that's where shapecasting comes into play. So as you can see, if I go ahead and run this now, the raycast missed, but now the shapecast, despite half of the shapecast not even touching it, it will still detect the hit, and you can see there it will stop and give you the information about what was hit. So that's why we're going to be using the shapecast instead of raycasting. The main difference is, like I said, the shapecast has volume and the raycast is just imagine it like a skinny line versus a line that's like huge. And yeah, without further ado, let's get into the second segment now. Alright, so the first thing we did was create a module script, and this module script will basically be the main code for like the projectile service. So as you can see, we're using object-oriented programming, and that's simply because we want to be able to use like different instances of a projectile, right? Because we want to have different types of projectiles, and each projectile will have its own custom behavior based on the information that's been passed in. So as you can see here, these are the methods we're going to be using. And yeah, if you couldn't already tell, this is the second time I recorded this because somehow I deleted the files. But yeah, let's just continue to the video. Alright, so as you guys can see, we created a couple of changes. The first thing we did was we made it so you have to pass in the origin and the velocity. The velocity is just a vector 3 for the speed that you want it to traveling in the direction, right? So for example, here I have the local script, and all I'm doing is I'm passing in the velocity. It's just my character's look vector times by 10, meaning that whatever direction my character's humanoid root part is facing, it will go 10 steps in that direction. Now, what I also did was I passed in the origin, and the origin is just the current position of my humanoid root part. Obviously, I use C-frame, that way it can be getting the direction it's facing as well. So, doing that, then I run the init method. The init method, as you can see, I added a couple of things to it. First things first, I added a spawn part method. This is just for debugging, so we can actually see where it's going, because currently we don't actually have the fireball moving. We just have like positions being stored in a table and stuff. So we want this just to visualize where it actually is. Then we create a run service connection, and we store it inside of this table that we made inside the new method, as you can see there. And then it's stored in there, meaning that we can access it later on and disconnect it, because we don't want the run service connection to be there forever. Now, if you guys are experienced coders, you probably already know what the issue is right now, but don't worry, I'm going to get onto that in a minute. As you can see here, we made the step method. The step method literally just updates the position and adds the velocity to the current position, and then we spawn our parts at the new position. So when I run the game now, you're going to see what I mean when I say there's an issue. When I press the ability, it spawns the parts and it moves correctly, but that is happening way too fast, and that is because I am running it is running every frame. So even if I was on lower FPS, I was on 60 FPS for example, you can see it's slightly slower, but it's still running all the way like way too fast. And that kind of shows you what it means, right? So if I was running at 240 FPS, first of all, it's traveling faster. And when I'm on 60 FPS, it's traveling slower. The way to fix this and make it consistent across all FPS is using delta time. Alright, so the best way to explain delta time is like this. Delta time is the time passed between the previous frame and your current frame. And when you're running on 60 FPS, the time it takes for each frame to render will be this time, 0.0167. That's how long it will take from the previous frame to update to the current frame you're on now. And when you're on 120 FPS, it is just that divided by 2. And then when you're on 240 divided by 4, and it keeps going, as you can see. Now, why this is useful is because if I were to, for example, run out, I want the projectile to move at 100 speed. What I could do is, let me just warn to the console, right? 100, then I'll multiply it by delta time. So in this case, let's just say I'm running on 60 FPS, I'll multiply it by 60 FPS. So now on the output, when I run the game, as you can see here, I get 1.67. So that 1.67 means that if I want to move at 100 studs per second, I need to move 1 stud every frame, assuming I'm at 60 FPS. And now if I were to do the exact same thing, except change this to 120 FPS, you can see here, now I get 0.83. So if you guys remember before, when I was on higher FPS, the projectile was moving faster. And when I was on a lower FPS, it was moving slower. This fixes it because now, when you're on 120 FPS, you're basically rendering 2 times more frames than the other person. Meaning that 2 times more frames. So if I were to times this by 2, to give basically what it would be if I wasn't on 120 FPS and I was on 60, you would see now I get 1.66, which is exactly what I got before, or close enough to what I got before when I just did 100 times by 60 FPS. So as you can see here, get 1.67, close enough, right? So the whole point of that is now, despite what FPS you're on, it's going to give you how many studs you should move relative to your FPS. I don't know if I'm explaining that well, but let's go back to the projectile service and edit it now. So run service connections basically pass in delta time as its parameter. So you can see here, we'll call it DT, but it means delta time. So now inside the step method, we're going to pass in delta time, and we're going to times the velocity by delta time. So now the position is equal to the current position plus the velocity times by delta time. So if we needed to move 100 studs, it would do 100 studs times by DT, which if it was on 60 FPS, we would get 1.67, meaning we're going to move 1.67 studs for that specific frame instead of moving 100 studs per frame, which is what was happening before. So now when I do that and I pass in DT here, if I were to run the game, and now when I press Z to use the skill, you can see now it's traveling consistently at this speed. And then even if I went to a different FPS, I went to I was already on 60, okay. Now say I went to 120 and I did another one, still the exact same speed, and it's moving consistently. And then obviously if I wanted to increase the speed, instead of doing 10 studs per second, I could do 100. And now, as you can see, it's moving consistently at 100 studs per second. So now that that's out the way, let's go on to the next part. Adding in gravity is really easy. So as you can see on my client script here, my local script, sorry, I added a gravity vector 3, and all it's telling it to do is move down 60 studs. Because my current speed, velocity, is 100 studs, meaning it's going to travel 100 studs every second. And I'm setting the gravity to be negative 60 studs. So when it's moving forward, it's eventually going to start having a downward turn until it hits the ground. And I pass that in as one of my parameters. And obviously I take it in here and I store it here. And then now inside of the step method, I set the velocity to itself times by the gravity, sorry, to itself plus gravity, then times the gravity by delta time. And the reason why we do that, as you know, we want how much it should go down. Let me just stop yapping. All right, so this is what it looks like now. As you can see, it has a downward curve and it's going to eventually hit the ground. And obviously if I was facing higher, it would still do the exact same thing. So if I'm here, we'll keep traveling until it hits the floor, which looks all good. Luckily, adding in lifetime is also very easy. So you can see here, we pass in the lifetime as a parameter, and here we see lifetime being 1, and I pass that into the script, and obviously I'll save it. And then what we do next is we store the start time in tick. Tick is basically Unix seconds. You don't really need to exactly know how they calculate Unix seconds because it's not that important, But let me give you an example. So if I want to just warn to the console tick, you can see here, I get that number. That number represents the current time in the game. So if I were to do next, let's say I task.wait 1, and I warn the current tick now. You can see here, the tick is this first, then it changes after 1 second. You can kind of see how it changed from 50 to 51. You can kind of see there, right? So using that, we'll be able to detect time change. So inside of the script, what I did was here, I did if the current tick minus the start times tick is greater than the lifetime that was passed in, then it will run the cleanup method. All the cleanup method does is it goes through everything inside the connections here. So this would be like your run service connections, any other connections you might want to have. It will loop through everything in there and it will disconnect it. Because if I didn't disconnect it, it would keep moving and it will just cause a memory leak because you'll constantly be running this every frame despite not doing anything. So you can see here, I set it to 1 second. So if I go up here and I do this, you can kind of see it stops after like mid-air, right? So let me just kind of get a better angle. Okay, you know, let me put it to a shorter time so you can exactly see what I mean. So if I put it to like 0.1, all right, it's going to stop down there instantly. You can kind of see here, it moves then stops. So that's how you can do a lifetime, right? So actually I have a really good example here. So if I did 3 seconds, then I spawned in, go to the server. I'm going to anchor my character, right? Then let me anchor it and rotate it like this. So now if I use it here, you can kind of see how it just stops midair, right? After 3 seconds, it goes, and then it stops right there. For a second, I thought it didn't work. I was like, wait, what? Okay, anyway. So now let's go on to the next part. All right, so for the max distance now, what we did was obviously the same thing. We passed in the max distance in studs that we wanted to travel. So for reference, like this is pretend this is 1 stud. Obviously, 1 stud is way smaller. Then we want a max distance so you can only travel a certain amount of studs. And after it does, it just kills. If it travels, no matter where it is, it just dies. So to do that, obviously we passed it in here, did the same thing there. But the one difference I made to this step method was that first of all, I cleaned it up, right? I called the velocity change displacement, and then the next position I stored in a variable. The reason why I did that is because we're not always going to actually update it, because we're going to be doing a check obviously to see if it collided with something. And if it's going to collide with something, we don't want to update its position, right? So that's the point of us changing the format. But here, all we're doing is we're getting the total traveled distance. To do that, I cannot speak. We're getting the next position, which is where it's going to travel to, minus the origin. Then we're doing dot magnitude. Magnitude is just, I guess you could say, the length in studs, because when you have a vector, the vector has direction and magnitude. Direction could be, for example, facing up, and then the magnitude could be 30 studs, meaning that the vector is pointing up in this direction at 30 studs. That's all that means. So what I'm doing is I'm basically getting just the length, and I'm checking if the length is larger than the max distance that you put in. And if it is, then it cleans up. So an example, I put in 20 as my max distance. So now if I use it, as you can see, it stops after traveling 20 studs. So if I were to change that to say 100 studs, and I were to like position myself like high up, like over here, and let me actually scale this up. And I want to position myself like over here. You're going to see now, it will let it travel up until 100 studs. Then it will stop, as you can see, at 100 studs there. So that works well. Actual moving of like the part or like the fireball that's going to be passed in. So we're calling it instance. So here, you can see here, this is just going to act like as a placeholder. So imagine this like your actual firewall VFX. And then inside the local script, I just referenced it here. I cloned it. And then I passed it in. And now, all I'm doing is, first of all, I'm disabling the spawn part because I don't need to debug it anymore since we're actually going to be using a physical part. Then inside of the step method, all I'm doing is I'm setting the instance C frame, which is, mind you, C frame is basically position and orientation, right? So all I'm doing is I'm setting this. I'm setting the C frame of the instance to a new C frame, and I'm creating a C frame from the current position and then the look vector, the unit of the velocity. So an example would be, let's say this is a vector, right? Let's just pretend this is a vector. If we were to get the vector's unit, you see this blue arrow? That blue arrow would be like the unit. Say the vector was looking in this direction, that blue arrow will be the unit. It will just be a magnitude of 1, but just a pure direction used for direction only, right? So if we were to do dot unit, we're getting the unit on the velocity. So for example, the velocity could be, I don't know, -100, and then gravity made it move down maybe -10 studs. So it'll move like this, a little bit like that. So if you were to get the the unit now, it's facing in this downward direction. And then because of that, we're able to make a new C-frame of it. And obviously when you do C-frame.new, you're able to pass in, you can see it takes in 2 parameters. And then we're setting the unit of the velocity added to our current position. That means that it's going to be facing that direction from our current position. I explained that horribly, but you guys get the point, hopefully. So now, if I were to run it now, you can see the part, it starts to slowly change direction to face the ground. So to better explain this again, if I were to do what I did before, select my character, anchor it, and rotate him this way. Rotate him a little bit less. Okay, you can kind of see now, right? It's going to take a while, but oh no, okay, let me change the gravity. I made the gravity like super low, made the gravity like -10. So then that'll be a better example. So let's do that again. So select my character, anchor him. I did not mean to do that, yo. Okay, rotate. All right, so now if I do it, you can see how it starts to slowly turn until it hits the floor. And we want that because we don't want it to just move normally, because if we didn't do that and we just set the position normally, so we just did, for example, instant stop position is equal to the next position. The issue now would be, as you can see, it works, but it just moves to the next position. It doesn't look dynamic, it doesn't look real. Obviously, we don't want that, which is why we did it this way. All right, so on to the next part. All right, so now what we added was the actual raycasting, or in this case, block casting, to detect when we actually hit a part or like the floor or something. So to do that, we passed in detection size. So detection size will just be a vector 3 for the size you want to detect around the part. But obviously in this scenario, we're just gonna pass in an actual physical hitbox. So you can see here, I passed in a hitbox here, and this hitbox is purely just to use this as a size. So I use the hitbox here, and I pass in the size value of this hitbox. That way I don't have to like guess it by code. And then I pass that in the client here. And then all I do is, before I set the position of the part and the next position of the part, I'm basically creating the raycast, but in this case, blockcast. So here are the parameters, and I'm excluding my character and excluding the workspace.fx folder, meaning that the raycast cannot detect my own character. So if I walked in front of it, it wouldn't detect my own character as a collide. And obviously you don't want it to collide with your own character. And then all I'm doing here is I'm casting the blockcast. And blockcast takes in quite a bit of parameters. The first parameter is the C frame that you want it to start at. Also, you could kind of say origin, then the cast size, which is the size of the hitbox we passed in, and the direction. And then we're going to use displacement, because if you guys remember, the displacement is basically the direction the velocity is facing in, as well as how far it travels within that specific frame, right? So we're using that to tell it to, okay, shoot from this point to this point and detect anything that was hit in between it. And then obviously passing the parameters so it knows to ignore my character and whatnot. Then all we're doing is we're checking if it actually hit something. And if it did, I set the position to the results position. Then I do the effects here, which mind you, I haven't actually coded this yet, but I'm passing in the result.normal, which I'll explain later. But yeah, if I were to run the code now, you can see it spawns in the part, then boom, it hits the floor. The second, you can see how it's not actually touching the floor, but the hitbox was touching the floor. So then it detected the hit. We do the exact same thing here. You can see it stops and it detects the hit very accurately. And obviously, if I were to walk in front of it, you can see it's not detecting my character. And then eventually, it works. So yeah. One thing I did forget to mention is, if the only problem with like block casting and stuff is, if for example I had a part that was already here. So let me make the transparency a bit different so you can actually see. So if I did the transparency to like 0.3, I'll do 0.9, 0.7. So you can see here, if I were to shoot it over here, it works correctly. And if I were to shoot it into this part here, as you can see, it works correctly. But if I was already inside the part and the part was already colliding with the other part before it started getting shot, you can see here, it still moves through the part. And that's a problem. We don't want that, right? So what I did was I created a method called initial step. All right, so for the initial step function, all we do is we spawn a physical part, and then we're checking if the part is inside if any other parts are inside the part. And if there is, which means it's collided with something, then we just return true. And mind you, it doesn't have to be a physical part. You can use spatial queries to do the same thing, but I decided to use a physical part for, I guess you could say, simplicity. And then all it does is if it does hit something that returns true, then back in the init function, when I run it, mind you, I run it before even creating a run service connection. I check if it did hit something, and in the event that it did, then it just returns. And obviously inside here, if it does, we do the cleanup. So yeah, so when I run it, as you can see, it works normally with the normal projectiles. And if I were to shoot it into this, you can see it works. But if I was inside of it, you can see it doesn't even spawn anything. And the reason being, it's automatically destroying. And the reason we do that is because obviously we'll show like VFX of exploding or whatever, like whatever you want to do for when it ends. So yeah. All right, so now we've got an added impulse. So what I mean by impulse is like, I guess you can say like a push, right? So if you guys remember at the start of the video how the skill looked, it kind of moved up and then moved down. For example, like before actually like, you know, traveling straight down, it moved up initially. That's what I call initial velocity, I think I called it. So an example of this would be if I were to go here and I can add 20, this would make it travel to up 20 studs first as well. So now if I were to run it, you can see it travels up 20, and then, okay, I think I might have broke something because that's not supposed to happen. Hold on. All right, so it actually wasn't an issue, just that it was actually just way too high. And what's it called, our lifetime was there as well, especially it just made it look weird, right? So now I put it to 2, so it only adds 2 initial velocity. So you can see here it starts to go up and then it starts to even out and go down, so it kind of looks like it's real. And obviously you don't have to add it, so I could just put like 0 and it would do the exact same thing except straight. And obviously since it's gravity as well, I could put 0 gravity and it would just travel straight after going up. So I think this will make it consistently travel up because there's no gravity weighing it down, as you can see. So it'll just continuously travel up. So yeah. All right, so I'm not gonna lie, like the ending of the video like literally deleted. I don't even know where the file is, but I'm just gonna be explaining it again, but this time a bit more briefly. So here is the finished code. Obviously this is copied from my original, so I'm missing like, I think the I'm missing one thing. I forgot what it was. I think it was the lifetime check, but obviously you guys already seen the lifetime check in my previous one. So what I'm doing here is on the client, all I'm doing is I am playing an animation. Then when the animation reaches a certain point, I spawn in a fireball. Then when it reaches the throw point, then I unanchor the fireball and I unroll it, and then I just fire the actual projectile from the position of the current fireball, which would be in my character's hand. Now, when you do all of that, you can see all I'm really doing is substituting the parts, kind of like the original system, right? So the fireball.cframe, the position, that's the origin. The velocity, I've defined it here. And then the rest of the parameters is exact same thing. And then I'm going to be explaining the surface thing though, because that part I didn't explain. So you can see here, boom, I just made it so when it ends, for example, when it detects a hit, it just displays a VFX, like emits a VFX. And then obviously I added camera shake, right? So to do the actual, like the flat thing, flat effects like this, like you see how it's like flat on that wall, but then it's flat on this ground here. To do that, inside of my VFX, sorry, my FX method, all I'm doing is I'm passing in a normal and a B. The normal is basically the surface that the raycast hit. So if I were to print this normal, it would be basically a vector pointing like this away from like the surface, right? So then I pass in a boolean as well. I'll explain why in a second. So what I do is I set the VFX's position, sorry, the VFX's C frame to a cframe.new. Then I'm passing the first parameter, which is position, to the self.position. Then the second parameter, which is like where it should look at, I'm doing the position plus the vector, sorry, plus the normal, which is a vector. So I'm basically telling it to look to spawn in this position and look in this direction. And doing that, it does this for you. But obviously you don't need to do the vector 3.new because this is not necessary. But if there is no normal, then it will just do this to prevent bugs. And then here I'm just timesing it by a new C frame, adding 0.125 studs to it, because if I added like a part and the part was like this, right, like flat on it, you can kind of see how that could cause some problems if there was VFX. So I add a little bit like this, just so it's not directly on the ground, but it looks like it is, just so the VFX has like as you can say, like a bit of room. But one thing you might want to also consider is you can see here, if I do show orientation indicator, this means the part is facing in this direction. So if I were to do this code currently on this part, it will end up like this. So when you're doing your part, you want to make sure the orientation is the correct way. So you'd want to do this and flip it to the right direction. Sorry, the right orientation, like this. So now, if I were to do it, it would work as intended. I just thought I should mention that. I don't think I originally did, because that could cause a lot of issues. And yeah, so now that that's out the way, I think that's about it, because nothing else have really changed. Yeah, I like the way it turned out. If you guys would like to see like the server side of it, I'm going to be doing a part 2 if this video gets like 100 likes. I think I mentioned that already, but yeah, in the part 2 I'm literally just going to be explaining how you would handle this on the server, because obviously in the server it's going to be a bit different, because you don't want to handle like effects on the server. You don't want to handle like, you know, too much stuff on the server, where the client is basically for visuals and the server is basically for like information. So yeah, without further ado, yeah, we out.